So today I thought it would be handy to take a look at how one goes about using an ESR meter. I was looking around trying to figure out, naively, as I've been learning about things, how can I figure out whether a capacitor is good or bad? And well, if you can take the capacitor, let's just move this to the side for a second. If you have a capacitor here, so here's an example, nice electrolytic capacitor, happens to be, I don't know if you can see that, if the camera will focus, but it's 470 microfarads. So, electrolytic, it's got a positive and a negative. So let's hook it up here. Oops, that's not the right. So negative, positive, so these are polarized. We'll take the fluke here, and we'll move the fluke onto capacitance mode, and lo and behold, almost dead on, 469 microfarads. And I've got another capacitor here. This one's 220 microfarads. Not so dead on, but 204. So kind of in the right ballpark anyways. So when you've got the capacitor just sitting out like this, measuring it with a meter, like the fluke, no problem at all. But when the capacitor is sitting in the middle of a circuit, then measuring the capacitor is not going to work with this sort of a technique, because you're going to end up measuring the capacitance or capacitance, various other devices that are sitting within the circuit, right? Because everything's all connected and wired up. So this is not so handy. But if you can't measure the capacitance with a standard multimeter, because it's all wired up, what can you do? And so that's where this ESR meter comes in. Now this is one I've seen on a couple of other vids, and I did an unboxing video, and there's a table here at the bottom that I hope is legible. And the idea is you can use this ESR meter, and I'll turn on in a second, but you can use this to test capacitors in circuit, okay? And it does this by injecting this 100 kilohertz test signal at a very low current level, so that it can't damage anything else, can't activate anything else in the circuit. It injects that 100 kilohertz signal, and it measures the resulting impedance. Okay, impedance being measured in ohms, but the impedance that it measures in ohms is extremely low, and you'll see that as we start to measure. And so what this tells you when you measure the impedance, it tells you whether the capacitor is good or bad, whether some people say the internal resistance, the impedance, whether it's at the right level. And so what happens is when a capacitor is good, the impedance is quite low. And what happens is when the impedance, when the capacitor breaks down, the internal resistance starts to rise. And so what happens is we'll get an impedance that is higher here. And so that's, you'll see how we figure it out through the table, right? We have to look it up, because if the resistance that's shown for one of these capacitors exceeds the value, okay, and that's a key thing. If the resistance exceeds the value, in the table, then the capacitor is bad. And so you can do this both, with the capacitor loose, but you can also do this with the capacitor in circuit. Okay, that's the wonder of these things. So let's turn this on. Okay, so let's zoom in on the display a little bit. Now, one of the things to note, okay, once again, so it's for testing electrolytic capacitors in circuit. And first thing we have to do is we want to zero these out. So we connect them and press 0. Okay, so now it's calibrated. And of course, because it's measuring such low resistances, it's picking up, it'll pick up the resistance and very sort of small fluctuations even in the leads. And so that's why the leads are sort of super short like this, right? You can see that like the test leads are really short. And that can be a bit of a pain, especially when you're used to working with leads that are, you know, 1 foot or 2 feet long. So now, the unit itself has information on the display, as you can see, which will tell you whether for the 25 volt range, which is sort of like the middle of the range, whether it's good or bad. But I don't have 25 volt capacitors handy, so let's hook this one up. So remember, this one is 470 microfarads. So I'll hook the negative up here and the positive here. Sorry, you can't see that. Okay, so we get a reading of 0.064. Okay, so it's a 16 volt capacitor, 0.064. So what does that mean? If we look it up in the table here, 16 volt capacitors are the second column, 460 microfarads. It comes out to 0.16. Okay, so the value that we measured, well, it's actually gone a little up now, 0.092, nonetheless. Less than, certainly much less than this maximum on the table for 470 microfarads. So this is a good cap, okay? Just has to be less. And this one, which is 220 microfarads, try to make sure I'm keeping these in the frame. Hook this up, and we'll hook this one up. And the reading is 0.197. If we look up for 16 volts for 220 microfarads, if you can see this here, okay, the value we're looking for is under 0.33. We've got 0.20, so that's good. Okay, so we've tested 2 capacitors. They happen to be not in circuit, but they've tested it okay. So, and we measured them earlier on the fluke. The capacitance was close to what's indicated on the label, so everything is good. So that's good. Now, one of the things that I should have done, but I didn't do, and you'll see that when we get to measuring something in circuit, one of the things you have to always remember to do, and I have to make up a little label that I stick on this, you always have to remember to discharge the capacitor before you use it, right? Now most of, and you can discharge the capacitor, I mean, with something like this, you can just touch the leads together, because there could be, in a capacitor, there could be some charge left over from when it was in operation, and the charge can blow the meter. It's very sensitive, as you could see by the very low values that it's picking up. And so you always have to remember to discharge. And so when we get to testing something in circuit, I mean, these aren't charged because I haven't really done anything with them other than test them. But when you get to testing something in circuit, you have to remember to always discharge the capacitor first. For really low voltages, you can just short it out with the test leads. But for really large capacitors that might be storing a lot of charge, that you could probably blow blow your fingers apart. No, you could you know, you could cause a bit of a spark or something if it's a very large capacitor and there's a bit of a lot of charge stored in it. All right, so let's have a look at how we use this in circuit. Now, one of the things you're going to see me using, um, you can't. I think I was mentioning you can't have very long probes, and so it's a bit of a pain because you can't get the alligator clips. You know, if you're working with surface mount circuits, you can't get these alligator clips anywhere near the contacts, right? So I created these little pseudo little probes, because the other thing is you don't want really long probes, so you can't take, you know, these 2-foot long probes from the Fluke or anything like that and stick them in here, because they're not going to operate well. They've got too much resistance. So I've made these little fake probe extenders, just a little piece of 14 gauge wire with a little bit of electrical tape. There's the positive one and the negative one, and you can see if I touch these two. Now I put the electrical tape on there so that my fingers are not causing anything, although my resistance is way too high. As a human being, my resistance is not low, but if I touch those together, you can see 0.021, so not quite the same as just touching the clips together. If I touch the clips together, come on. 0.0, you can see it kind of varies around a little bit. If I get good contact, 0.03, so that's, you know, I've zeroed them. So I'm gonna have to re-zero when I'm using these, okay? But this is what I'm going to use, because you need something to be able to get down to the pads where the capacitors are soldered onto the board. So let's have a look at what that's like. Okay, so I've got this Onkyo receiver. Kind of see the whole bench here. I've just zoomed out, and this receiver does not work. The HDMI board has a failure on it, and I spent a lot of time trying to reflow the Dolby chip. There's a lot of videos that show reflowing that chip there that is in the center of the frame. So I tried doing that. That did not help. A little more research said that it could be the capacitors that are on this board. The top board is called the HDMI board. Capacitors on the HDMI board might have blown, or at least some of them have. So there's 5, 6, 7 or 8 electrolytic capacitors sitting on top of this board. So we're going to test these out and see if they're working. I'm going to have to set the camera up in a way that allows us to see all the details here. So just give me a second. But the idea is we're going to test, there's a batch of capacitors there, and there's one sitting right there on its own between the connectors. So let's have a look. Okay, so I've tried to get everything in the frame so you can see me both with the leads and you can see the readout on the meter. The first thing I've got to do, remember, is discharge the cap. So I've got a little piece of wire here, and I'm just going to short out the pins. The wire may be a little too fine for what we're trying to do. If I was doing this with something that had been on in the last month or so, I'd probably use a test lead as opposed to that. So now I've got this capacitor. The capacitor is labeled as being 100 microfarads and 16 volts. So now it's really finicky because and that's why I've created these little extenders to get onto the pads. But the pads are on the top side, so if I've got, that's the negative, the positive. Okay, so that reads out as 0.136. Okay, 0.136. And if we look at that up, if we look up 100 microfarads on the 16 volt column here, 0.7 is the maximum. So 0.136 is completely acceptable, completely within range. So that's a good cap. So we don't have to worry about that. That won't need to be replaced. I'm just going to reposition everything now for the big gaggle of other capacitors. Okay, now all the other capacitors that I'm going to have to test are here. So the first thing I want to do is I want to discharge these. Remember, just in case, it's always good to, never too late to practice good technique. And especially considering that I'm going to have to get used to doing this as soon as I start energizing these circuits. So there I've gone through and I've shorted them all, so any residual current should be discharged. So the first one that I'm going to test, these capacitors all have different voltages. So some of them are 16 volts, some of them are 4 volts, and one of them is 6 volts. So a little bit of an odd mix. So first we're going to test the one closest in the frame. And like I said, it's a little bit of a hassle because the probes are so short. So let's try to get this into the right spot. It's very finicky, especially when you've got these short little alligator clips. There, I've got the positive, negative. I don't have the positive and the negative. Okay, so now I'm reading 2.22 or 2.23. You can see that in the frame. And if I look up, okay, 2.23. If I look up 100 microfarads at 16 volts, the maximum, the maximum of 0.7. So that's about 3 times higher than the max. So this one, this cap right here, that's bad. So probably should mark that. Okay, so I've got a red Sharpie here. I'm just going to put a little red dot on that. So I'll remember that that's a bad one. Let's move on to the next one. Fortunately, the black and red are in better orientations. This one is 47 microfarads, 16 volts again. And so that's reading 4 roughly. So if I look up 47 microfarads, 16 volts is 1.6. So that's also bad because it's way above what it should be. So let's mark that with the Sharpie as well. A little red dot, so that's bad. This other one is 100 microfarads at 16 volts. It's a little tough to just, you know, these are so short that the wires put some force back here. Okay, I'm just not making good contact there. Okay, I'm just going to get a magnifying glass out. Make sure I'm getting this lead onto the terminal or onto the solder point. Get some hair there. Okay, that's the negative. That's the positive. Come on. Okay, so that's reading 0.19. 0.19 for 100 microfarads, 16 volts. So that one should be good. Okay, now I'm going to do the one beside it. Got to flip these over. Negative terminal, positive terminal. Okay. Okay, that one's being fussy too. So let's make sure I've got this. I'm getting the contacts. Let's rotate the point to the tip here a little bit. These pieces of wire I've filed down the tips, so they're not perfect yet. Might have to work on that. Okay, that should be in contact there. Okay, here I'm getting 0.21. Okay, so that's 0.21. 0.21. Now that's 220 microfarads. 220 microfarads, and we have to go with the 10 volt column. 220 microfarads at 10 volts comes to 0.6. So this one should also be good. Now let's go to this one. This is 220 microfarads. And everything is very small here. Let's just get this one in contact. And this one. Okay, I'm not in contact. Okay, 0.22. So 0.22 for 220 microfarads is fine. So those three are good. And then the last one is this big one here. There, and there. And that's reading 0.618 or let's say 62. Okay, so 0.6. This is a 470 microfarad. So 470 microfarad. The max here, once again, this is a 6 volt. The table only goes down to 10 volts, but if we go from this, 470 microfarads should be no more than 0.24, and it was 0.62. So this one's also bad. So Sharpie, mark this. Okay, so now I've tested these three caps, and you can see that we had so there's 6 of them here, and of the 6 here, 3 of them tested out bad, and 3 of them tested out okay. And so the real question now would be, okay, let's remove them from the circuit. And if we remove them from the circuit, we could run them through a regular meter like the Fluke, and either we'll get the capacitance or we won't. So I'm going to try to desolder the larger of the 3 caps here, and then we'll measure it out of the circuit and see what happens. Okay, so now I've got the hot air station set. It's gonna put out 380 degrees. It's just warming up. Nope, 360 degrees. I'm gonna try not to blow anything else off of the board. I've got some tweezers here that I'm just gonna use to push this. Okay, that's one end that's come off. And that's the other end. I hope I haven't ripped off the pads. All right, so we've pulled the 3 caps off of the device, out of the, and I did not pull off any more solder pads, so I'm very grateful for that. I only have to deal with the one that I knucked up. Note to self, use less force when desoldering with hot air, or anything for that matter. So now that we've got them out of the circuit, let's give them another test. So I've kind of bent down the little SMD mount pins just to make it easier to get the clips on here. So this one is 100 microfarads, and so that's reading 1.50, 1.5, and so if we look up 100 microfarads at 16, the max value should be no more than 0.7. So at 1.4, 1.5, that's double the max value. So that one is definitely bad. This one is 47 microfarads at 16 volts. So we'll connect this one. And boy, am I glad that these alligator clips work well. Okay, and that one reads 2.72. So if we look at 47 microfarads at 16 volts, it should be no more than 1.6. So that one's also bad. And here it is, the large one that caused me so much grief. This is the 47 microfarads at 6 volts. Oh no, 470, what am I saying? 470, the last zero there was a little tough to read. So we'll connect that there. And connect this one here. And you can see the reading there is now 0.39. And so if we look at 470, 470 at 10 volts is 0.24. So 0.39 it has exceeded that. And so this one is also bad. So the values that we got were a little different. Let's see if we can focus on that. Maybe not. The values were a little different than we got in circuit, but in all cases, the ESR values for these caps turns out to have been bad. The other ones should be okay, so then these are the ones that I'm going to have to try to order, and we'll see if I can then replace them in that HDMI board, and maybe it'll come back to life, or maybe I've messed it up in some other way, or maybe there's some other problem. And you'll also notice that I put this always discharge sticker here on the ESR meter, which once again I didn't do. I did it just before I started recording. I discharged all of these in preparation, but you can see it's something that is really easy to forget, and I really need to get into the habit. Always discharge. It's a I don't know. Let's say it's a really it would be a really kind of dumb way to mess up an ESR meter by not discharging. So really, it's a practice I need to get into. I mean, discharging these would be as easy as kind of taking for these small values. You know, you could take a little clip there and connect it. You could take a random alligator clip and connect them. I mean, these have very low charge, you know, just like that. There's a very low charge in these, and so, and you know, they're also very low voltage, so they're not going to be super dangerous, but enough to mess up a sensitive electronic device, probably. And I'd rather not find out just exactly what it takes to mess up a sensitive electronic device. So there you have it. All right. I hope this was useful. I do have to say, one of the things to be aware of, actually, and this is an important thing. If we measure the capacitance on this device, on this capacitor, the capacitance is going to read out to 100 or pretty close to 100 microfarads. So even though the ESR is bad, okay, so let's go through that again. So let's remember to do this properly. So let's okay, so let's remember to discharge these. So screwdriver method, and let's connect the two leads. Okay, so I'm getting 1.28, 1.3. So for 100 microfarad, that's about double what it should be. Okay, so even though I'm getting a bad ESR, one of the things to notice, okay, so this is definitely a bad cap at this point. If I take the fluke here, and switch it to capacitance, and let's measure the capacitance. Okay, so I'm just going to do this back here so you can see that at no point do my hands leave my arms. Okay. Okay, so it measures out pretty close to 100 microfarads, which is fantastic. So that might lead you to believe that it's a functioning capacitor. And also true for this other one. This is 47, I think. Yeah, 48. Oops. 47.9, 48 microfarads. So if you were just to measure the capacitance, you might get the impression that these are fully functional capacitors. And, well, nothing is further from the truth. Through the ESR, we've seen that the internal impedance, the internal resistance of the capacitors is over spec, and so these are not operating the way they're supposed to. There's a ton of stuff that you can read about this on the net. Unfortunately, there's a lot of bad information out there as well that tell you, you know, as long as you pull, if you pull the capacitor out of circuit and measure the capacitance, you know, you can tell if the capacitor is good or bad. Turns out that that's not true. If you pull them out of circuit and measure the capacitance, they might read the correct capacitance, but the ESR would be off, and so these are not good caps. And so what that tells me is that the ESR meter here, lurking in the background now, this is sort of the only reliable way, at least only reliable, easy way of testing a capacitor, both in circuit and out of circuit. Because, like I say, you can pull them out of the circuit and you can run them through a meter with a capacitance test, and it'll give you the expected capacitance value, but even though the capacitors are not functioning properly. Okay, well, I hope this has been helpful for you, and thanks for watching, and please subscribe so I feel motivated to keep making these videos. Bye for now.